Hi all, and I welcome you to my YouTube channel Math Universe with Dr. Naseer Ahmed. Having completed limits in part 1, now it's time for derivatives. Derivatives will be a basic for our entire second PUC calculus, and again I would like to complete the concept in detail and then followed by the problems. Now let us focus on derivatives. See carefully. Understand. Let us again go with the geometry. See, let us suppose we have got a curve and the curve is this y equal to f of x. Now, if you can see the function, we are taking a function, always our derivative will be on function. See carefully that if I take a particular point on a general point, let it be x, and for visualization I'm taking the other point bit far, and the point is x plus h. So it also means that the distance from here to here is x, correct? And the distance from here till here is x plus h. It's very basic now concept that whenever you have got any point p of x comma y, this length from here to here is x and the length from here to here is y. So the distance in the point P and on x-axis will be y, and the distance between the origin and the point lying on x-axis will be x coordinate, whatever is mentioned here. So with that, always this will be x values and here again x plus h. Now when I substitute x is equal to here x itself, I'll get y to be what? F of x. So the corresponding value is here. So this will be f of x. And again when I put x is equal to x plus h, then I will get a corresponding value here. That is f of x plus h. So the point here will be x comma f of x as a point P, and the coordinates are x comma f of x. Geometry we are analyzing what is its derivatives, okay? Then this point Q, the x coordinate is x plus h and the y coordinate is f of x plus h. Okay, now let us join PQ. When I join PQ, as you can see, it's a chord. See this? Yeah, it's a chord. Now we are going to fix one of the point, whether it be P or Q, and we are going to walk along this curve y equal to f of x here. We are going to walk. Now when I'm going to walk, let us suppose I'm here, okay, and this point is, let us suppose q1. Now see carefully, when I join this, my chord which was PQ, now this PQ1, so the chord has become a bit smaller, and as and how I just walk through this curve, nothing but see, when I'm walking through the curve, I also mean to say that I am coming near to x, correct? No, because for this corresponding number will be here, right? So again it's here, ultimately touches the curve at the point this, and this chord shorten like this, and ultimately it becomes a tangent here. It becomes a tangent. So derivative or differentiability, if y equal to f of x represents a curve, then the first derivative stands for slope of the tangent. And if we just see this carefully, here we have got this one, I can regard as x1 comma y1, and this is x2 comma y2. So there are 2 points. So limit, as we are this distance you can see is h. because see, very simple. No, if I say this entire length I've got, and I know this length, what is this length? So this length will be from the entire, I have to subtract this, then I'll get this. Similarly, I repeat, this we have a marker, I know this length, I want to know this length, the cap. So from the entire, I should remove this, correct now? Similarly, I know this length and this entire. So how to get this length? From this entire, remove this. When I remove from this entire, this part, x minus x will get cancelled, I'll get only h. And this distance, now I have taken a bit bigger so that you can see the diagram. It's very small there, and we are approaching, okay? And we call slope formula, it is y2 minus y1 divided by x2 minus x1, slope of a line passing through 2 points from chapter straight line. So here also y2 is f of x plus h minus y1. What is y1? F of x divided by x2 minus x1. What is x2? X plus h minus x. So as h is tending to 0, this both will get cancelled, and that's what we get our first principle. This we call our first principle. Mind it, this is x which is getting cancelled. And this is known as first principle. So if we have been given y equal to f of x, then the rate of change of the quantity represented as dy by dx. So in place of writing this such a entire expression, we just write dy by dx. How to read this? Derivative of y with respect to x. This is the independent variable, as you know, x is independent variable. Whereas y, nothing but f of x, is what? Dependent variable. So you should understand here that we are always differentiating a dependent variable with respect to an independent variable. Okay? And whatever we have got here, this we call first principle. Of derivative. So we'll be having some question, find the derivative by using first principle. Then we are going to use this formula. As you can see, rate of change of y coordinate divided by rate of change of y coordinate divided by rate of change of x coordinate. Here x and minus x got cancelled, I got only h. Okay. Now this is with respect to general point. Let us suppose that I want to evaluate the derivative at x equal to a. Then before that, this we also write f dash of x. See the difference here. Y equal to f of x. To represent a derivative, the first derivative, this we call first derivative, means differentiated only once. Throughout our first PUC, only derivative only once with respect to x, the independent variable. So if y equal to f of x is given, f dash will stand for first derivative. Okay, you should be very thorough with the notation. Either f dash of x or dy by dx represent first derivative of the given function y equal to f of x. And if I evaluate at x equal to a, then f dash of a is equal to derivative of y with respect to x at x is equal to a. Like this also we can write, or derivative of y with respect to x. We can have both the brackets. Okay, and we can also have like this also, derivative of, in place of y, what is that? F of x at x is equal to a, all are same, is equal to, here limit, in place of x it is a. So put here a plus h minus f of a whole divided by h, as h is tending to 0. So this will be used when we want to find the derivative at a particular point by using first principle. This will be in general. All our 3 marks are on this. And by using this only, we are going to derive all the derivative results. Let it be x power n, sin x, cos x, tan x. Okay, and even the second PUC also. I want you to understand this notation. And one more thing, here f dash is there, so you can also write this one as derivative of f of x with respect to x, nothing wrong here, I want some space, is equal to f dash of x. So all these notations are same. In place of writing like this, we can write dy by dx. As soon as I write dy by dx, if I'm saying by using first principle, this is the definition. Okay, and this is finding the derivative at a particular point, x is equal to a. Obviously, a is a real number. Okay, so, and let I comment one most important thing. What? If y equal to f of x represents a curve, then the first derivative is slope of a tangent. Slope of a tangent. That's what you can see. That this chord, which was PQ, slowly just came, ultimately both got coincide, and I got a tangent. Okay, PT, let us suppose PT. Okay, slope of the tangent. So with this, we are ready for the problems. So concept is presently this much. We'll go for first principle, finding the derivative. Kindly make a note. Okay. Dear students, having understood the derivative concept, now it's time to go ahead with some derivation. This is not from question paper. It's theorem number 6. I know you'll be thinking what about theorem number 5. That will be on algebra of derivative when we are going to have more than one function. Let us try to first complete all the standard derivation by using first principle, and then we are going to talk about algebra of derivatives of two functions. Now, theorem 6 says derivative of f of x is equal to x power n is n into x power n minus 1. We have to prove this, and n is any positive integer. Let us prove this. And in exam, if this comes, this is also a usual question, and they'll say by using first principle. By using first principle. So we have to memorize that expression. What is that expression? See, proof. So whatever the question is given, first write as y. Don't forget, f of x is always what? Y. Now by first principle, definition, what do we have? We have derivative of y with respect to x. Don't spell no dy by dx. Doesn't look good. Derivative of y with respect to x is limit of f of x plus h minus f of x divided by h, as h is tending to 0. Okay. Now see this. In this I want f of x, that's a question. I want f of x plus h. I'll ask you a simple question. If I ask you what is f of a, what do you do? In place of x, replace by a. So here a power n. Correct? No? Correct? No? But now what I want? F of x plus h. So here in place of x, I want x plus h. So replace x by what? X plus h. So this is my equation number 1. This is my equation number 2. So substitute here. So limit of what is f of x plus h? X plus h whole power n minus f of x is x power n whole divided by h, as h is tending to 0. Now apply the limit. If I apply the limit wherever h is there, h is tending to 0. So I'll get x plus 0 will be x power n minus x power n divided by 0, and you can see very clearly that x power n minus x power n both are getting cancelled, so I'll get 0 by 0 form, nothing but indeterminate. Now let us see carefully. This is a binomial expansion. Recall what is the binomial expansion. A plus b whole power n is equal to nc0 a power n b power 0 plus nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 b power 2 plus last term is ncn a power 0 b power n. It's very simple to remember also. See, you have got nc0, nc1, nc2 and move on ncn. Now in this a plus b whole power n, a is the first term, b is the second term. See the first term, that is a. Always your first term is difference of this two. N minus 0 is n. That's what you can see here. Again, difference of this n minus 1, power of a is n minus 1. Here, n minus 2, power is n minus 2 here. Again, n minus n is what? 0. Whereas power of b is the index present. You see, 0, so 0. Again, power of b, 1. How? You can see the index. You can match with the index here. Again, index of this nc2 is 2, so 2 here. Here the index is n, so it is n here. Okay, that's how you can remember this. Now let us apply this. Listen carefully, pay attention. So only for this I am going to apply binomial theorem expansion. In place of a we have x, in place of b we have h. N remains n. So come on, apply this thing for this term. nc0, then a is what? X power n, then b is h power 0 plus here again nc1 x power n minus 1 h power 1, then plus nc2 x power n minus 2 h square. Correct? Just I have substituted. Then plus, let us write in next line, dot plus ncn x power 0 and h power n. So that is the expansion for this, minus x power n. And this entire term is divided by h. H is tending to 0. Recall some of the result from combination. It is nc0 1, nc1 is n, and also ncn is 1. I am only concentrating on first term, second term and last term. That's sufficient. So see carefully, limit nc0 is 1 into x power n as it is, h power 0 is again 1, then plus nc1 is n, so again I will get n here, then x power n minus 1, then h power 1 is h plus, okay, this term no problem, I can write, anyway it's not going to affect our result, then plus dot ncn 1 it is, x power 0 is also 1, it's multiplication, don't think as a decimal here, it's a multiplication, then h power n minus x power n, and this entire term is divided by h, where h is tending to 0. Now see carefully, what is 1 into x power n into 1? This entire value is x power n, and this is getting cancelled with this, both are getting cancelled. Now what is remaining? See carefully. If you just see carefully, in the remaining, okay, first let us write the remaining term, n into x power n minus 1 into h, that's for this term, then nc2 x power n minus 2 h square plus dot plus 1 into 1 is 1, 1 into h power n whole divided by h. Now in the numerator, see what is common, h is common. Since h is common, remaining n into x power n minus 1, so h is common here. Since h is common, h square will become only h because one h is taken out. So plus nc2 x power n minus 2 h plus dot dot dot. Since h is taken common out, here I have got h power n, so it will be ultimately be h power n minus 1. Why? One h is taken out. Okay, whole divided by h. Can you see? H is tending to 0. So the term which will give 0 by 0, that is getting cancelled. H by h got cancelled. When I apply the limit, see second term, h is there. So this will be going to 0. This will be tending to 0 because h is tending to 0. This will be tending to 0. All the other terms also will be having h. And this last term also will having h. Is there? H is there, tending to 0. The only term which is remaining is this. So what is that? N into x power n minus 1. Don't forget the left hand side. Our left hand side is derivative of, see here, derivative of y with respect to x. So derivative of y with respect to x. So the left hand side derivative y. What is y from equation number 1? It is x power n. So derivative of x power n with respect to x is n into x power n minus 1. A very standard important result. What is derivative of x power n with respect to x? It is n into x power n minus 1, where n is any positive integer, nothing but n is a natural number. I hope this is clear. And I think some people will be having a doubt. What about the remaining element? For that, come back here. See binomial theorem expansion. Second term b, power of b increases from 0, then 1, then 2, then 3, up to whatever the power we have got here, it attains. So when I'm expanding this, second term is h. So power of h is 0, then 1, then 2, then 3, then 4, ultimately n. So it means whatever the term we have not written here, it has got h cube after h square, h cube, h power 4, like h power, like that, h power n minus 1. So even if I take one h common here, the way I have taken here, surely the remainder is what? Since I have got here h square, next term is h cube. If I have taken one h common out, I'll get h square here, then h cube here. Surely h term will be present. Since I am applying the limit, h is tending to 0, all the h gone. Okay, it is tending to 0 only. And one point I want to highlight, in derivation in NCERT, they have assumed n to be positive integer and then we have derived so that we can apply binomial theorem of PUC. But this result, let I write it here, note what? Derivative of x power n with respect to x is n into x power n minus 1. Be careful, power of x is n minus 1. Let I write it again. X power what? N minus 1. And here n can be any real number, need not be only integer. So this I wanted to quote as a note. Who knows, for 1 marker they may ask for which all number it is true. Okay, but for derivation we have taken as natural number. Okay, I hope this point is clear. Make a note. Okay. Dear students, now let us move on to the next problem, and this is from model question paper number 1. Question says find the derivative of f of x with respect to x from first principle, given that f of x is sin x. Straightforward question could have been find the derivative of f of x equal to sin x with respect to x by using first principle. No problem. Okay, and this is from PU board, model question paper number 2, 28th question, and for 2 marks. So after that I'll take cos, then tan, then we'll go for the remaining. Okay, now you see, so the proof, or yeah, better I can say proof of this. See, they said by first principle, first in the question they are given f of x will be sin x. So I want to find the rate of change of sin x. That's the meaning here. And this is y. Now by first principle, by definition of first principle. What are we going to have? It says derivative of y with respect to x is limit of f of x plus h minus f of x whole divided by h, as h is tending to 0. F of x is sin x. I want f of x plus h. Same logic. Replace x by x plus h. We will have sin of x plus h. So this is my equation number 1. This is my equation number 2. Again substitute here. Limit of f of x plus h is sin of x plus h minus f of x is sin x. So we have just got from equation number 1 and 2 divided by h. How we got? From equation number 1 and 2, and h is tending to 0. Now first you apply the limit. Always apply the limit by direct substitution and see what you are getting. Wherever h is there, replace by 0, h is tending to 0. So this will become h is tending to 0. So I'll get sin x here minus, because of this minus, then sin x divided by h is tending to 0. So here 0. Both will get cancelled. So what I will get? 0 by 0 form, indeterminate form. Now, surely you cannot apply method of factorization here, but I can apply limit sin x by x as x tends to 0, the result which we have derived in limits, but for that to be applied, it should be a product form. It is a difference form. So recall in trigonometric function, phi marker, we have discussed on transformation formula. Okay, transformation formulae. So now this is of the form sin c minus sin d. So recall that formula. What is sin c minus sin d? It is 2 times of cos of c plus d by 2 into sin of c minus d by 2. This is the transformation formula. And there we have discussed the phi marker and gave all the 4. Now see carefully, my dear students. In place of here, no, sin, sin. See how I came to all this formula? You can see sin minus sin. So sin c minus sin d. Here we have c. If I compare with this, x plus h is c, and d is nothing but angle x. Okay. So having this logic, I hope this is looking better. This is c. Okay, now apply the formulae. Limit of 2 times of cos, add the angle divided by 2. Angle is here x plus h and x. So here we have x plus h plus x whole divided by 2. Then sin here, subtraction of angle. Find what is c, x plus h minus of d, that is d is x here. So x plus h minus x whole divided by 2. And don't forget we have divided by h. Now h is tending to, okay, let us write a bit more up. H is tending to 0. Okay. Now see carefully some simplification. Can you see both plus x and minus x is getting cancelled? And here we have limit of 2, okay, like 2 times of cos. What is x plus x? 2x. Then plus h divided by 2. Then here sin of h by 2. Now be careful. I have got divided by h. Surely under multiplication numerator, see this. If I have got here 2 into 4 into 6 divided by 2. You cannot divide this 2 for all the 3. Any one you can divide. Either you can say 2 ones are 2 ones are, or 2 ones are 2 twos are, or 2 ones are 2 threes are. I mean to say like this. Either you can divide like this, and answer is 6 fours are 24, or same if I have taken 2 ones are 2 twos are. So 2 twos are 4, 4 6 are 24, or 2 ones are 2 threes are. So 3 fours are 12, 12 to 2, 24. So what I mean to say, you can divide any one term, not all the three. So this h also can divide any one of it. I am going to take it here. Wiser, I can apply this result, limit of sine x by x as x tends to 0. The value is what? 1. So you can see the angle should be same. Angle is what? H by 2. I have got only h. Now what I can do? This 2, I can write it down. I am sending this 2 to denominator. Now you see, I have to apply the limit very easily. Can I say that this limit should be applied for cosine also and this entire term? So when I'm applying the limit for this entire term, and this is exactly satisfying whatever the angle is here, same angle here. Angle is h by 2, so same h by 2. So I am going to get for this, after applying the limit, it to be 1. In algebra of limit we studied, for product or sum we have to apply for each and every term. Then cosine 2x plus h is tending to 0, so h will be 0 divided by 2. Let us write it properly. 2x, h is tending to 0 divided by 2. So you can see 2x plus 0 is 2x. 2 and half got cancelled. So what I'm remaining? Cos x. What is the left hand side? Don't forget left hand side. Derivative of y with respect to x. But what is y? Y is y? Y is sin x. So derivative of sin x with respect to x is cos x. This I came to know from equation number 1. Okay, so I hope the things are clear. I would like to stress this once. Derivative of y with respect to x. As we know, in y equal to f of x is the independent variable, y is the dependent variable. So we are always differentiating dependent variable y with respect to independent variable x. Kindly make a note of this. Okay, dear students, having completed derivative of sin x with respect to x by using first principle, let us move on to cosine. Actually, this is not from the question paper, but as I said, let us try to learn the things in detail. So we have to find derivative of f of x with respect to x. Given that f of x is cos x, or they can say find the derivative of cosine function. Don't forget, when I say cosine, it is nothing but y equal to cos x. Okay, and this is the problem from exercise 12.2. Let us go ahead. Now I have written some of the things because first principle formula will not change, and whatever the question they have given, that is our f of x. Now since f of x is cos x, I want f of x plus h. So replace x by x plus h. So I'll get cos of x plus h. That is our equation number 2. Apply it. Substitute here as we want first principle. So this formula will never change whenever you go for first principle. So cosine of x plus h minus f of x is cos x divided by h, as h is tending to 0. Okay, now apply the limit wherever h is tending to 0. So wherever h is there, it should tend to 0. So I'll get cos. Again you can see method of direct substitution we are doing it. Only then we come to know 0 by 0 form or not. And all for trigonometric this time, we are using limit sin x by x as x tends to 0 as 1 value, that is equal to 1, that we are using. Okay, so h is tending to 0. So cos x minus cos x divided by h is 0. H is tending to 0, so 0. Now cos x minus cos x both will get cancelled. So I am going to have 0 by 0 indeterminate form. Now this again I am going to use transformation formula. Coming to transformation formula, see carefully, this is a form cos c minus cos d. Recall what is cos c minus cos d. It is minus 2 times of sine of c plus d by 2 sine of c minus d by 2. You have to at least memorize these two formulae, okay? Hardly two formulae coming to by using first principle. Right, and practice. Now, Josh is required to study. Will is required. Now, see carefully. Cos C. Cos this entire is what? Angle C. Then cos D. This entire is what? D. So, limit of minus 2 times of sine at the angle x plus h and x I have to add. So, x plus h plus x divided by 2 sine of c minus d. C is x plus h minus d. D is x divided by whole divided by 2, okay, and we have by h, okay. Now the thing should get better. Now same procedure. Now see some of the term getting cancelled. Can you see? X minus x both are getting cancelled, so is equal to limit of minus as it is sine, okay, 2 times of sine x plus x is 2x plus h divided by 2, then sine of h by 2 whole divided by h. Same logic of last, okay, h is tending to 0, don't forget this. Now limit minus sine of 2x plus h whole divided by 2 sine of h by 2, and this h can divide either 2 or sine or h by 2, so I'm dividing with this so that I can use the formula, and this 2 I'm shifting it down, so divided by 2. Now see carefully, we know the formula, limit of sine x by x as x tends to 0 is what? 1. So angle should be same. Yes, you can see we made the angle same. That's why we took 2 down, okay, to denominator. This denominators, okay, different denominator. So this by applying the limit, and again here also we are applying the limit. So minus sine of what? 2x, h is tending to 0 divided by 2, and this entire value is 1. Now from here 2x plus 0 is 2x, 2.5 is getting cancelled, so I got minus sine x. Don't forget the left hand side is always derivative of y with respect to x. But what is y? What is y? Cos x. So in place of this y here, derivative of cos x with respect to x is minus sin x. Again, this is from equation number 1. What I want you to remember is all about derivative. Whenever we are talking about sine, cos, tan, all the 6 trigonometric function, the angle is in radian. Angle is not in degree, it is in radian. Okay, make a note. Okay, dear students, having completed cosine, now the next function, and this is from model question paper number 1, question number 38 for 3 marks. As we are aware that this model question paper is of the academic year 2024-2025, issued by PU board. Question says find the derivative of tan x with respect to x from first principle. Just they have reframed the statement, no problem. Now tan x, I assume the given question to be f of x, tan x. Now again by first principle I have to go about, and since I have got f of x plus h, d plus x by x plus h here, so I will have tan of x plus h. Now again if I substitute, See carefully. Limit of f of x plus h is tan of x plus h minus f of x is tan x whole divided by h, where h is tending to 0. Now apply the limit. This says wherever h is there, replace by 0. When I do so, nothing but tending to 0. Okay, so h is tending to 0, so I'll get tan x minus tan x divided by 0. Both tan x will get cancelled because signs are negative. Tan x minus tan x gone. 0 by 0 form nothing but indeterminate. Now coming to tan x minus tan of x plus h, I repeat, tan of x plus h minus tan x, there is no transformation formula. Transformation formula is there only for sine and cosine. Then what to do? Whenever we stuck in trigonometry, go back to basic. Which are the two basic trigonometric functions? Sine and cos. Correct? So what is tan definition? What is tan definition? Sine by cos. So tan of x plus h will be sine of x plus h, okay, divided by cos of x plus h minus, because minus is here, tan x. What is tan x? It is sine x by cos x. This entire thing I'm taking in a bracket. And don't forget h is in denominator, so 1 by h. I don't want you to get confused here. You will write whole divided by h, then you are confused whether the divided by h, whatever you write here should be a multiple to this cosine or should go to numerator. So to avoid that confusion only, no, wherever it is present, denominator, I wrote it here. Now no confusion. Now it's a fraction type. I have to take LCM, and I have to take LCM because I got minus sign in between. So take the LCM. So first 1 by h as it is. What is LCM of cos of x plus h and cos x? Product of both. It is same as LCM of a and b is a into b. So cos of x plus h into cos x. Now divide this LCM by the denominator of the first fraction here. Cos of x plus h will get cancelled. I'll get cos x. Cos x into the numerator, I will get sine of x plus h into cos x minus, again this divided by cos x will get cancelled. I'll get this. So cos of x plus h into sine x. Okay. Now compound angle formula. This resembles, the numerator resembles one formula. Sine x cos y minus cos x sine y is, is what? I wrote right hand side resembling, see, sine, cos, then minus cos and sine. What's the formula? You should remember both the sides. So this is what? Sine of x minus y. So I'm going right to left. So when I compare with this formula, in place of this x, we have this term. And in place of this y, we have this term. Again, in place of x, we have this term. Again, in place of y, yes, it is completely, you can see both are same. So I'm going to apply right to left the formula. So see carefully. We are having limit 1 by h sine of x minus y. What is x? X plus h. Then minus y. So minus, what is y? X. Divided by cos of x plus h into cos x. As h is tending to 0. See carefully. Is it not both plus x and minus x will get cancelled? What is remaining? Sine h. Sine h into 1 is sine h. divided by h into 1 divided by cos of x plus h into cos x, as h is tending to 0. And this you see ready-made formula we got. What is that formula? Limit of sine x by x as x tends to 0 is what? 1. So when I apply the limit for this and this term, this entire term will give us what? 1. And 1 divided by cos of x plus h is tending to 0, so this will be 0. Then cos x as it is. X plus 0 is x. So what we are going to have? 1 divided by cos x into, again this cos x as it is. What is cos into cos? Cos square. So 1 divided by cos square. But what is 1 by cos? 1 by cos is secant square x. Yes, this is the result. Don't forget left hand side, dy by dx. But what is y? Tan x. Y is tan x. Therefore, derivative of tan x with respect to x is secant square x. What is that? Secant square x. And I got this from equation number 1. Okay. So, for even in PUC, NCRT, only sine, cos, tan derivative by first principle is asked. So I thought even I'll cover cos also. Okay. Remaining, when I will solve question tool problem, no, that time I will discuss. Now let us move on to one more model question paper problem on first principle. Okay, dear students, on first principle, this is the last question from model question paper number 3. Question says find the derivative of f of x is equal to 1 by x square with respect to x from first principle. Okay, so let I erase this. This is the last problem I'm yet to erase. Okay, ready? And let's go ahead. Okay, so in place of f of x, we have been given 1 by x square. Now, since in first principle we have f of x and f of x plus h, in place of x it is x plus h, replace it. Now see carefully, substitute first here. Limit of, what is f of x plus h? 1 divided by x plus h the whole square minus f of x is 1 by x square. Now be careful, divided by h, again to avoid the confusion, write it here. You will never have a trouble. When you write whole divided by, you have always a trouble, but it will come ultimately here only. Okay, in denominator. Now apply the limit. Wherever h is there, replace by 0, nothing but tending to 0. So see carefully. This, okay, here we have 1 by 0 for this term. Then here 1 divided by x, h is tending to 0. So x plus 0 is x, so x square minus 1 by x square, right? So this will get cancelled. I will get what? 0 by 0, because here this will be 0, 0 to 1 is 0, and this 0 as it is. Nothing but we get indeterminate form. Now, previously, we had trigonometric function due to which we applied transformation formula. Ultimately one product. Here, we don't have trigonometric function. Simplify it, nothing but take LCM. How to know it's LCM? It's a fraction separated by sign minus. Whether you have minus or plus, having a fraction like this, what we have to do? We have to take LCM. So limit of 1 by h. What is LCM of x plus h square and x square? It is product of both. X plus h the whole square into x square. LCM of this two. Now, LCM divided by the first denominator term, x plus h square, will cancel this, remain is x square. This x square into numerator 1 will be x square minus this divide by this x square will get cancelled. Remaining is x plus h the whole square. H is tending to 0. Now simplify. X square. Now see carefully, this is of the form a plus b whole square. Recall what is a plus b whole square formula. A plus b whole square formula is a square plus 2ab plus b square. So here we have a plus and plus balances, and this is our b if I compare with this formula. So now when I apply the formula for this formula for here, I'll get x square then plus 2xh plus h square. Many students will do this error. Minus is there, you can see here, this minus is multiplied to be multiplied whatever the expansion I get for this. Many students will not give the bracket, due to which this minus is getting multiplied for the first term but not for the remaining, which is an error. You can see yourself, no, this minus should be multiplied for the entire solution of this, but what is happening without bracket? If I don't give any bracket like this, it is only multiplying to this, but it should multiply to the entire term. So opening and closing bracket, whole divided by x plus h the whole square into x square. As h is tending to 0, limit 1 by h, we have got x square minus into plus is minus x square, minus into plus is minus 2xh, minus into plus is minus h square, whole divided by x plus h the whole square into x square, as h is tending to what? 0. Now plus x square and minus x square will get cancelled. So the what is remaining term? Limit 1 by h. Here we have minus 2xh minus h square divided by x plus h the whole square into x square. What is common in numerator? See carefully. The common term is h and h here. So limit of h is common. So h out divided by h. Then minus 2x, 1h gone. Only 1h was there out. Common here taken. Here h square is there, but 1h is out. So only 1h will be remaining. Divided by what? X plus h the whole square into x square. H is tending to 0. Don't forget to mention. So very clearly you can see that h by h getting cancelled. Nothing but the factor which will give 0 by 0 form is getting cancelled. Okay. Now apply the limit. Wherever h is there, it should tend to 0. When we do so, see, minus 2x, h is tending to 0 here, divided by x plus 0 the whole square into, not minus, into x square. Now here minus 2x divided by x plus 0 is x. We have a square into x square. See carefully, one x term will get cancelled. This x will get cancelled with one of the x. So here it is 1, correct? So x square into x will be x cube. So I am going to have minus 2 divided by x cube. Here we have derivative of y with respect to x. Don't forget the left hand side. But what is y? What is y? 1 by x square. Therefore, derivative of 1 by x square with respect to x is minus 2 by x cube from equation number 1. So first make a note of this. Okay, dear students, with respect to first principle, all problems done. Now we will take algebra of derivatives, and then we will take some formulas followed by quotient rule, which is a 4-marker short question. Okay, make a note. Okay. Now, dear students, let us move on to algebra of derivatives of two functions. Algebra of derivatives of two functions. You can have more than two also, but first presently understand for two. Now, first principle, when we had only one function. First it was x power n, then sin x, cos x, tan x, and lastly was 1 by x square. We had only one function. Now let us suppose we have two functions f and g, and I want to apply differentiation. So first, let f be a function from a to b, and g is a function from a to c. Again, I am saying the domain should be same for both the function, and derivative of both f and g are defined. Nothing but it is differentiable in their domains and common domain, that too. So as far as I've taken a and a. If this is the case, okay, and if derivative, then it can happen that I can have sum of two function. So sum rule. First rule is I can have sum of two functions. So sum rule, nothing but in between the function f and g, we have addition. How to differentiate, how to read this? Derivative of f of x plus g of x with respect to x is derivative of f with respect to x plus derivative of g with respect to x. Nothing but differentiate one by one. And don't expect a bracket, it's understood. Derivative as soon given, whatever amount of terms are there, all should be differentiated. So some rule says one by one you differentiate. Even if I've got more number of terms, differentiate one by one. Okay. Second one, difference rule. Now coming to difference rule, as the name suggests, between the two functions we should have subtraction, minus sign. So derivative of f of x minus g of x with respect to x, same like this, differentiate them separately. That's it. No, we are saying just differentiate one by one. Next, we are also having product rule. Nothing but, let us suppose between the two function we have multiplication, product rule. So and this derivation is not there in the syllabus, only the formulas are important. So I'm just giving the formula with the logic. So when to apply this, I've got derivative of product of two function. So as per the order, who is first here? F is first, f of x is first, and this entire g of x is second function. So the rule says keep the second function as it is, then derivative of first function with respect to x plus keep the first function as it is, then derivative of second function. This is called product rule. Now, if we take f of, and here no, if you change the order, this is second, this is first, then also no problem. You can see here, you can see no. If we go with this order, I have kept the second function as it is, differentiate the first function, then keep the first function as it is, differentiate the second. Now, if I take this as first and this as second, the order will get extended. Since we have plus sign, no matter, even if you change the order also, no problem, you'll get the same answer. Now, in this, if we take f of x to be u and g of x to be v, and if we substitute in equation number 1, then we are going to have in place of f u, in place of g v. So u into v, and in place of writing derivative with respect to this symbol can also be used. This symbol dash stand for derivative, first derivative. So you can just see, applying the same logic, this is the first function and this is the second function. So keep the second function as it is, differentiate the first function, so u dash, plus keep the first function u as it is, differentiation of, keep the first function as it is, differentiation of second function. And this we call Leibniz rule, is called as Leibniz rule. Okay. Now here when I went for product rule, both are variable function. Variable function means f and g, you can see x contain nothing but they are variable, they are going to change as and how x changes. But one special case of this scalar rule means that when we are multiplying and we want to differentiate, among this one is a scalar function. So derivative of k into f of x, where k is a constant. Now if I apply the product rule only, as per the product rule, you can see k is the first function and f is the second function. So we have to keep the second function as it is. I given the numbering, so we go with the numbering here. Keep the, see, than going for fg, no, I would like to go like this. Derivative of product function when we talk about, keep the second function as it is, differentiate the first function, plus keep the first function as it is, differentiate the second. Let us go with the number than going with the fg. See here. So here keep the what? Second function as it is, differentiate the first function, plus keep the first function as it is, derivative of second function. What is derivative of a constant? Let I give the result here. Derivative of any constant, derivative of any constant with respect to x is always 0. For example, derivative of 7 is a constant, so 0, any real number, if you take it is 0. Similarly, derivative of minus 8 with respect to x is again what? 0. Okay. So derivative of a constant is 0. So k is a constant. We are saying here k is a constant, a scalar. It's a constant. Therefore, derivative of k with respect to x is what? 0. 0 and f is what? 0. So I'll get only what? K times of derivative of f of x with respect to x. So derivative of k into f of x with respect to x is this result. So from here one thing is very clear, that scalar rule is a special case of product rule, and whenever is a constant is there, we can always avoid the product rule. See, we applied product rule and then we got this. So we can always avoid product rule. For example, if I give you one question, derivative of 2 into sin x. No need to apply the product rule for this because 2 is a constant, sin x is a variable. So as per this, see, in place of k, 2. In place of f of x, sin x. So take 2 out. Derivative of sin x. What is derivative of sin x? Cos x. And this 2 is kept as it is. That's it. Next comes the last one, quotient rule. See, whatever we are discussing, this one, no? Second piece also is doing same thing. There you are going to have composite, I think, but more than one function, combination of more than one function. So these are our basic. You should memorize this for our which marker? 4 marker. Okay, for this year, 4 marker question. Now comes quotient rule. As the word suggests, we are going to have ratio of two terms. So derivative of f of x divided by g of x with respect to x. I want to find the derivative of this. This is same as, see carefully. Then saying no, fg, I would like to say numerator denominator. This is there in denominator, dr I will call, and f is there in numerator, so I will call nr. So square of the denominator, that is g of x. Keep the denominator as it is. Derivative of numerator, that is f. As soon as I say derivative, d by dx is given. To represent, I have to find the derivative. Minus, keep the numerator f as it is. Then derivative of denominator. That's it. And here, order is important. Here the order is important. The numerator, denominator, you cannot extend them. You have minus. What benefit we had here that we can extend also, that benefit we don't have here. Okay, this is quotient rule. Now, see, coming to this quotient rule, no, let us have, yeah, here I will take it. We can also go like this. If I just write u by v, what? U by v, and I want to differentiate. We can also call u by rule, u by v rule. So, I'm applying this dash stand for finding the first derivative. So, the rule will be same with this. Key square of denominator, who is the denominator? V. So v square. Then keep the denominator, that is g, as it is. So what is the denominator? V. So keep v as it is. Then derivative of numerator. So what is u derivative? U dash. Then minus. So minus. Then numerator as it is. What's the numerator here? U. Then derivative of denominator. What is v derivative? V dash. So u by v rule. Both are same. This is also same as this. In place of f and g, it is u and v. Both u and v are variable functions. Just a function, it can be variable or just a function. Similar here also. But for this we have got a special case. Okay. This you have to learn. I have spent the time. I have made you understand summary of the story here. For sum rule and difference rule, you have to differentiate one by one. For product rule, you have to treat one function as it is, differentiate the other, then plus keep the first as it is, differentiate the second. Coming to scalar rule, whenever we have got product of a constant and a variable, kick out the constant, remove the constant out, differentiate the variable. This is a special case of product rule. Coming to quotient rule, numerator, denominator, square of denominator, then keep the denominator as it is, derivative of numerator minus, keep the numerator as it is, derivative of denominator. And for our 4-marker question, quotient rule is coming repeatedly, but remaining is also required, especially this 2 rule. Okay, make a note. Now I'll give list of formulae. Make a note of this. Okay, fine. Dear students, having understood algebra of derivatives of two functions, now let us move on to standard formulae, which we are going to use while finding the derivative. Let us quote here. Okay, formulae on differentiation. The first one, derivative of x power n with respect to x is n into x power n minus 1, where n is what? Any real number. Second formula, derivative of x with respect to x. This is special case of this. You can see in place of power n, here we have 1. So put here 1 minus 1 will be 0. X power 0 will be 1. 1 into, and n is also 1, no? 1 into 1 is 1. Don't say cancel, okay? Rate of change of x with respect to itself is 1. Real world problem, if you think as change of, see, we depend on time. Time is the independent factor where we all are depending on time. So derivative, if I take, means rate of change of me with respect to time, there is a variation. But if I say I want to find rate of change with myself, it's always the same because it's taking with respect to me. Okay. Next, derivative of any constant which we have not derived is anyway 0. Remember the formula. For example, derivative of 8 with respect to x, there is no change, 0. Derivative of -7 with respect to x, again what? 0. Derivative of root 2 is again what? Constant, any real number, 0. Derivative of 1/3, it's a fraction, constant, real number, so again what? 0. So derivative of any constant is what? 0. Next, what is derivative of sin x? We derived today with respect to x, it is cos x. Then what is derivative of cos x? Fifth formula, with respect to x, it is minus sin x. What is derivative of tan x with respect to x? Is secant square x. Then derivative of cot x. So I'm giving the remaining also. I think space is not sufficient. Take in next line. Derivative of cot x with respect to x is minus cosecant square x. Derivative, 8th formula here. Derivative of cosecant x with respect to x. Is it visible that side? Yeah, visible. Okay, is minus cosecant x into cot x. Lastly, derivative of secant x with respect to x is secant x into tan x. See, 4, 5, 6 we derived, 7, 8 and 9 without derivation I have given. Even in NCERT also they have not asked the derivation directly. It is just been asked to find without using first principle. Okay, so I think with this, yeah, sufficient. We can go ahead with the problems on question 2. Make a note of this. This formula should be the perfect along with algebra of derivative. So coming to 4-marker question, you should be perfect with that 5 and this 9. 5 plus 9, 14. Write and practice. Okay. Make a note. Okay. Dear students, now we are ready with 4-marker question, which is short problem from this chapter. But that's not the only thing. Coming to second year PUC, as I said, 5 chapters are under calculus. Even for CET in second year PUC, even it will be JEE means also, questions are more from calculus. Coming to CET, you can say out of 60 questions, 15 to 20 will be from calculus. 5 chapters. Okay. Now listen. So that's what. No, make sure, be perfect, learn this basic formula. When you are going to be in second PUC, hardly 1.5 months. Okay. Then you will be in second PUC after 1.5 months or so, and you will see so much important these things are. Okay, don't neglect it. That's the reason I went for each and every concept. In place of taking as one video, making as one video, I went for 2 videos. Question says find the derivative of this solution. Let the given question is y is equal to f of x is equal to x power 5 minus cos x whole divided by sin x. I think it is too light. Let I fill the ink. Yeah. So let us proceed with this. Now, since we have to find the derivative, 4-marker question, question number 47. So differentiate. This is not by using first principle. Mind it, they are not use the word first principle. So you are going to use algebra of derivative and get the answer. Differentiate with respect to x. Now, we have more than one function. How many? X power 5 1, cos x 2, sin x is 3. So we have to apply algebra of derivative. Now when I want to differentiate, so I will apply d by dx. This is an operator which will say I have to differentiate. See, when I am writing like this, first understand the importance of this d by dx. Now, for example, if I give you two numbers and ask the result, what is 37 result? You will not say the result until unless between these two I will not define the operation. So if I give you plus, I want to add 3 plus 7, 10. If I give you minus, oh, I have to subtract 3 minus 7 is minus 4. If I give into sign, oh, I have to multiply 3 sevens are 21. I hope this logic is clear that we want an operation between these numbers. Similarly, the operation here is derivative. D by dx serves like plus, minus and multiplication. D by dx, whenever we see, oh, we have to differentiate. And now when I want to differentiate, since both numerator denominator are variable, I have to apply quotient rule. Recall what is quotient rule formula. Derivative of f of x divided by g of x with respect to x is square of the denominator. Keep the denominator as it is, that is g. Derivative of numerator minus keep the numerator as it is into derivative of denominator. Okay, this we call quotient rule. I'll just write QR. Okay, quotient rule. Now see carefully. In place of f numerator, this entire term is your numerator f, and this entire term is your denominator g. So now let us apply the quotient rule. So which says square of the denominator, so sin x whole square. Then g, nothing but keep the denominator as it is. Then derivative of what? Numerator, that is x power 5 minus cos x minus, okay, this bracket is overlapping, minus, keep the numerator as it is, x power 5 minus cos x into derivative of denominator sin x with respect to x. Now, wherever d by dx is there, that, as I said, no, plus minus into, so wherever is there, only then I am going to perform the operation. I am not going to perform the derivative here, only for this, wherever d by dx is there. Now see carefully. This x power 5, among all this, which formula? X power 5, x power n, yeah, this formula. So I'm going to use, so answer will be, in place of n we have 5, so put here 5 into x power 5 minus 1. 5 into x power 5 minus 1. Then this minus as it is, 5 minus 1 is in power. Write it properly. It is in power. Then this minus as it is, derivative of cos. What is cos derivative? Minus sign. Be careful. This minus as it is, and one more minus because of this formula. So minus sin x. Then minus of, there is no d by dx, so written as it is. Derivative of sin x. Derivative of sin x is cos x. Whole divided by, see, this whole square I can also write like this, sin square x. Now see carefully, do we have anywhere d by dx? No, it means we have finished the differentiation. We have to we have to simplify this. Nothing but school days concept. Just simplification. Let's take it here. So see carefully, 5 minus 1 will be 4. 5 into 1 will be, see here, sin x I should multiply here. So sin x into 5 will be 5 times of sin x. And here x power 5 minus 1 is 4. Then minus into minus is plus. What is sin into sin? Sin square x. minus into plus is minus x power 5 into cos x. Then minus into minus is this minus into minus what, plus. Then cos into cos will be cos square x. This whole divided by, this entire term is divided by sin square x. Now last step. What is sin square plus cos square? 1. Then see in this 2 term. See this 2 term. Something is common. X power 4 here, x power 5. So common is x power 4. If I write x power 4 common, then this is out. 5 sin x I will get. Then minus. Be careful. X power 4 is out. So only here x power 5 is it. Power 4 is out. So I'll get only x. Then cos x. Okay. Fine. Whole divided by, mind it, this is plus 1. Right, again, because of this reason. Correct now? What's the reason? Sin square x plus cos square x is what? 1. What's the value? 1. And divided by sin square. For this, we are going to get surely 4 marks. Next year, not get 4 marks. Mind it. Hardly will get 2 marks. Why you are getting 4? Because you are learning for the first time. Same like now, a plus b whole square, a minus b whole square. In 6th or 5th time when you used to apply this formula and get the answer, you used to get more than 2 marks or more than 1 mark surely. But now it's a part of the problem. No marks for that. So when you're getting for the first time, use it. Take to the greatest opportunity and get 4 on 4. Okay? Make a note of this. Okay. Dear students, let us move on to the next 4-marker question from model question paper number 2. As you know, issued by PU board. Okay. We have to find, okay, let us write this. Differentiate sin x plus cos x by whole divided by sin x minus cos x with respect to x. Again, the given question we are going to take as f of x. And make sure, remember that it is not by first principle. Surely by first principle it will be very lengthy. And what do you think? If we solve the same problem by first principle, whether we'll get the same answer what the way we are getting, or it will be different? Think and comment in chat box. Comment box. So differentiate with respect to x. So sin x plus cos x whole divided by sin x minus cos x. I have to differentiate this. And now, since I have got both numerator and denominator as variable function, I have to surely apply quotient rule. So this entire thing is f and this entire thing is g. Be careful that we have a denominator. Now what this says? Square of the denominator, g, this is f, correct? Square of the denominator, then keep the denominator as it is, then derivative of numerator. What is that? Sin x plus cos x minus, keep the numerator as it is, then derivative of denominator. Now wait, derivative of denominator, it is sin x minus cos x. Sin x minus cos x. I wrote the other way around. Sin x minus cos x. Let us check once. Yeah, everything is perfect. Now let us find the derivative. There is no dy dx for this term, so it will retain as it is. Now see carefully. Here I have to apply sum rule. Derivative of, by sum rule, plus sign is there. Derivative of sine. What is sine derivative? Cos x. And you should mention the reason. In working column, you should mention the reason, which of the formula we are using. The way I have mentioned here. Derivative of sine x is what? Cos x. Then derivative of cos x is minus sin x. This minus into plus will be minus sin x. Then minus of sin x plus cos x as it is. Derivative of sin x is cos x. Then minus derivative of cos is minus sin x. So already one minus is there. And from derivative of cos, one more minus, correct? You can see the minus here, okay? Let I give a rectangle bracket. Whole divided by sin x minus cos x, the whole square. Now differentiation completed. We have to simplify. Now if you see this one, sin x minus cos x and cos x minus sin x, if I take minus common either from here or here, both will become same term. Then we can apply, think of simplifying bit faster. So I'll do one thing. This anyway we are not going to use, so I'm going to erase this. Let I erase this. The part which we are not going to use. Now see carefully. If I take minus common from here, then we are going to be left with, if I take what? Minus common. So minus into plus sign will be minus sin x, and minus into minus will be plus cos x. So I write in order. First I will write cos x. I repeat again, minus into minus is plus cos x. Then minus into this plus sin x will be minus sin x. Then this term as it is. Okay. Then here you see minus to minus is plus. So let us write this term here only. What is the simplification of this? We get cos x as it is. Minus to minus is plus sin x. So sin x plus cos x into cos x plus sin x. Is this like this? No. A plus b into b plus a is same as a plus b the whole square. So I'll get what? Sin x plus cos x the whole square. Okay, I repeat again. See, this is like a plus b, and this is b plus a. Can you sin? Yeah, sin. Cos or cos. What is this? Both are same term. Since bases are same, we can add the power. Power is 1 plus 1 whole square. So a plus b the whole square. So I will be getting a. That's the reason I'm getting whole square. Whole divided by. Okay, whole divided by denominator. Sin x minus cos x the whole square. Now again you see this term a minus b into a minus b term. I think but bases are same. Power is 1. Add it. So I'll get cos x minus sin x the whole square. Then minus this one. Expand by using a plus b whole square. What is a plus b whole square formula? It is a square plus 2a. Okay, a square plus b square. It will be advantage for us if you got it like this. Plus 2ab. Correct now? This is b square. So this is your a and this is our b. Okay, a and b. So apply. So I'll get sine square x plus cos square x plus 2 times of sine x into cos x. And bracket mandatory. If you won't give a bracket here, this minus will multiply only for the first term but not for the remaining. Whole divided by. And one more thing, have we missed anywhere sign? No, okay. For this rectangle bracket, the bracket is getting closed here only. Okay, fine. For this rectangle bracket, minus is there here, right? So minus, and it is getting closed here only, correct? Let's check once the bracket. Yeah, there's nothing else than that. So we are going to have the same way. Now, if I have got a minus b whole square, if I have minus here, then I have a square plus b square minus 2ab, correct now? So see carefully. So this is again a, this is your our b there. So minus is getting this minus is getting balanced with this. So we are going to have from here cos square x, then plus sine square x by using this formula, then minus 2 times of cos x into sine x, minus what is the value of sine square x plus cos square x? Recall, what is sine square x plus cos square x? The value is 1. So this entire value is 1. Then plus 2 times of sine x into cos x as it is, whole divided by sine x minus cos x the whole square. Okay. Now again, what is the value of this? Again by using this, the entire value is what? 1. So now let us simplify. See carefully. Minus into plus 1 is minus 1. Minus into minus is plus 2 times of cos x into sin x. Minus into plus is minus 1. Minus into plus is minus 2 times of sin x into cos x, whole divided by sin x minus cos x the whole square. Okay, the whole square. Now see, one term is getting cancelled. 2 cos x sin x plus and minus 2 sin x cos x is getting cancelled. What is minus 1 minus 1? It is minus 2. Whole divided by sin x minus cos x the whole square. So this will be the answer. If you see, differentiation got over here only. This all steps are what? Simplification. So simplification of basic knowledge, but at least try to do it till here. Okay, fine. Make a note of this. So dear students, we are with the last problem. Question says find the derivative of f of x, which is equal to x plus cos x whole divided by tan x with respect to x. The last problem. So let us take the given question as f of x, anyway it is given. And again you can see all the problems are in quotient rule only. So differentiate with respect to x. So here square of the denominator by using the same quotient rule. This entire thing, don't forget, this entire denominator is g and this entire numerator x plus cos x is f. So square of denominator. Keep the denominator tan x as it is. Derivative of what? X plus cos x. X plus cos x minus, okay, f of x, correct? F of x, or is f of x? X plus cos x into derivative of tan x. Okay, let us move ahead. Tan x as it is, applying some rule for this. Derivative of x with respect to x is 1. We already discussed that. What is cos derivative? See carefully. What is cos derivative? It is minus sign. So minus into plus will be minus sin x. Then minus of x plus cos x. What is derivative of tan x? Secant square x. Whole divided by tan square x. I can write the whole square as like this on the trigonometric function, not on the angle. Now, see this. Yeah, for this problem, this is the end. Okay, so make a note of this. I'll be giving the assignment from previous year annual examination paper 2024. Okay, dear students, we have finished all the problems, but let us just take a problem, okay, where we have to find the derivative of this, but at a point. Okay, so we have not discussed any problem as such, so I thought we'll take, and then the assignments already have displayed, okay, from annual board examination. So just see carefully. Find the derivative. So derivative of x square minus 2. Before that, let us go step by step. Let us take the given question as y. Okay, they said derivative, nothing but differentiate with respect to x. So applying d by dx, nothing but derivative with respect to x on both the sides. Here, as you can see, difference of two terms. So I have to use difference rule. Let I erase this. I have to use difference rule now. So I have to use difference rule. So I have to apply for this and then this. Recall the formula. What is derivative of x power n with respect to x? It is n into x power n minus 1. So in place of n we have 2, correct? So what we get? 2 into x power 2 minus 1. Derivative of minus 2. 2 is a constant, so 0. So we get 2. X2 minus 1 is 1. 1 x power 1 is x itself. So derivative of y with respect to x is 2x. I want to evaluate at x equal to 10. So at x equal to 10. So after you find the derivative, then you should evaluate at a given point. Okay. So it is d derivative of y with respect to x. See, in place of writing like this, no, they can also ask derivative of y with respect to x at x is equal to 10. Already discussed at the beginning of this class. So in place of x it is 10. So 2 into 10 will be 20. Fine. So rate of change of this function at x equal to 10 is 20. And this is your assignment. One more thing I just wanted to highlight. In all our model paper, total number of questions are 47. But in annual board 2024, you will see 52 questions are there in total. Don't think something like out of syllabus questions are asked in 2024. No. Reduction of syllabus, as per that they have asked. But till 2024, number of questions in mathematics was 52 in number. Then what they did, they reduced to 47 total number of questions. So you will not see any out of syllabus in this. Okay, so don't think that some out of syllabus questions are there in 2024. Okay, I hope this point is clear. So after 2024, they have reduced the number of questions to 47. Okay, fine. So make sure you have made a note of all this. Okay. So with this part 2 on limits and derivatives come to an end, and this is also end for limits and derivatives chapter. Make sure I have tried my level best to give the clear concept and solve all the problem and also some extra problem, which is going to make sure not only first PUC, even your second PUC base is very strong. You have to only work, nothing else. Whatever amount of time you have got left, give your 100%. Don't misuse your time. Time is precious. Okay. So make sure study well, hard work, pay attention, learn, have rigorous know that I want to achieve a great height. Okay, so fine. All the very best. God bless you all. And do share, like, and subscribe to my YouTube channel, Math Universe with Dr. Naseer Ahmed.